Smart Industry, the Dutch Industrie 4.0 program, together with the development of smart services. 4 years ago, we started in the Netherlands as a reaction on the German Industrie 4.0 with this Smart Industry program, in which it was not only about manufacturing environment such, of course, very important, but also on all the developments on services. And since that time, when we started this program, I am there the program director. In this presentation, I'll go into, after an introduction on the acceleration of technology, or actually digitalization, the growing importance of data for the business, the demand really for lifelong learning. After that introduction, I don't go into details immediately on manufacturing as such, but I first expand it into what's happening around manufacturing, in particular, what's happening really with servitization. The products we make, the smarter products we make, the servitization possibilities with it, the data collection you'll do with it, and also the impact of more CO2 costs in the products and the desire to go to more sustainable production. With that context description, I'll focus on the manufacturing, what is changing in the manufacturing environment, how we try to make the logistics even so far that we can have a deep chain planning and control, that we also know what the status, the real-time status with all the suppliers is. How can we then change our factories that we can go to lot size 1, zero defect, those kinds of developments, robotics introduction, AGV introduction, and finally, of course, all the demands for continuously lifelong learning. Industry is changing faster. Most of you know all the different industrial revolutions, really. But a good thing to demonstrate what you're trying to achieve with industrial revolutions is productivity improvement. And there's a good example of what you could call a zeroth industrial revolution on sustainable means like wind and wood, is this sawmill. It used to take about half a year to saw a tree with 2 men, but with the introduction of the sawmills in the Netherlands or the Dutch society in the 1600s, really, it was able to do that in a week. So there was a 30 times productivity improvement. Those kinds of things you want to achieve. It's all about improving the productivity and manufacturing environment. And with the increase of data, you'll see that it is even expanding, and that's what I'll show you in the next slide. What is happening at this moment is, of course, we had Moore's Law and the mainframes were costly, but then software became available and the mainframes became cheap. Actually, you could say first was the age of IBM, then the age of Microsoft. And then what happened when PCs became affordable, the software became more affordable, the bandwidth was limiting really, until internet got introduced and bandwidth hardly cost anything anymore. And what we now see is that all of a sudden you have those platforms where the Googles and the Amazons and Microsoft again, of course, really monopolize a situation and make a lot of money out of it. But that's still an environment where you could call it the Internet of People with the PCs and the mobile networks. But what is changing at this moment is that all kinds of devices become smart, the Internet of Things as they call it. The fact that you have billions of those devices interconnected with wired, wireless, all these kind of developments. All those Internet of Things devices data can be collected, can be processed to a level of even artificial intelligence. And the question is, what kind of Internet of Services will there occur? And this is really this fourth industrial revolution, this trend from what we have till today, really an Internet of People towards an Internet of Things and an Internet of Services. Let me explain that services. It used to be that you were purchasing a box and that was it. Then at a certain moment people start realizing that it was not only about the purchasing price of the box to get the thing you wanted to realize, but also the total cost of ownership. So they started to optimize on it. Until at a certain moment it was not so much anymore about the total cost of ownership, also the personalization or the specialization of it. The uniqueness was gaining more important because for your application it needed to be a little bit different than for someone else. And that ultimately will lead to what we call servitization, where you don't purchase a product anymore, you buy or lease a solution in which a product is part of it, but where also the whole services and the managing of the services is essential in it. And therefore at that moment it's also much more ICT driven instead of traditional physical production. Now, as I mentioned, industry is changing faster. We had the zeroth industrial revolution with wood and wind. almost 150 years, 6 generations you could call. Then you had the first industrial revolution, the second, the third, the fourth. And what we really see is that within one generation, you face an industrial revolution. And that means actually that for the first time in mankind, we have a situation that you can't reach retirement anymore with the things you learned at school. If, for example, you're 35 years or older, quite often, 20 years ago, you could say that when you had the age of 15 and you were at school, you didn't have internet. It was just appearing. And you didn't get any digital training in those times. Now we have this Internet of Things, connecting everything to everything, which results in this smart industry. But in 10 years' time, we'll have artificial intelligence, we have quantum computing, all these kind of things. Technological things you can predict a little bit, but you cannot predict the consequences for your job and the kind of knowledge you need by that time. So this lifelong learning is for the first time in mankind a necessity. And to explain a little bit what needs to be achieved is, and these are the cases for the Dutch society, we now produce for every FTE roughly 100k euros on a yearly basis. What we'll see to follow inflation of say 2% over 20 years, but also the fact that you'll probably be learning. It will cost half a day to a full day each week. So in the other 4.5 days, you have to become more productive, catching up inflation, catching up this lost production time because you have to do on training. And also in the Dutch society, we'll know that in the next 20 years, we'll have 1 million people less, about a sixth of them out of the 6 million people working in manufacturing and services in a broad sense. So we do know that we have to increase productivity the next couple of years. And we cannot do it in the same way as doing more of what we did yesterday. We have to do it more smarter. And for example, what that means is that people will get better tools to perform, and those tools will be digital. For example, assume a situation that you have 2 welders on the shipyard, one of the age of 25, the other of 50 years. 20 years from now, the 50-year-old guy has left for retirement. And the 45-year-old guy at that moment has to produce twice as much. You cannot weld faster. So what you'll see by that time is that he got tools in the sense of 2 robots which are continuously welding, and the third one he can be programming at that time. That means that a welder in a couple of years has to know how to operate on a robot. And that is going to happen in much, much more jobs. Because if you really envision the ideal factory, what you'll want to have is 0 defect, for example. Every product step, 100% vision controlled, quality controlled. If you do that, you can go to just-in-time lot sizes 1. You can switch from one product to another because in cycle time you can change over your computer program and produce another product. It also means that instead of having large batches, you'll have shorter, smaller batches. That means that your robot, you can't reprogram anytime the robot. If, for example, a customer asks for the same product but a little bit longer, you don't want to reprogram the robot. You really want to download 3D drawings and automatically adapt the robot on it. These kind of things, a 0 defect, 0 programming, 0 tooling. Why wait 3 months for a mold if you can get it with 3D printing the next day? 0 delay, such that you have this lot size 1 really and deep chain planning control. 0 surprises with predictive maintenance, and which is definitely necessary in servitization when products are at customer sites and you want to maintain them. 0 waste and 0 dropout. That's a lot of 0 ambitions, and that's what we will focus on. Servitization. I'll explain servitization as driven by smart products, the Internet of Things really, that it is about a new business model. A business model which initially will not be picked up by every company, but in the long run, once CO2 taxation increases, it will become a standard way of working. What you see in here is that in Internet of Things, all products really become smart products because it becomes so easy to embed computing devices in it. This moment it's getting already smaller and smaller, but what also is a case is that the number of devices really starts to explode. What you see here is really the learning curve of it. 3 is really 1,000 in double logical. This is 1 million, this is 1 billion, and this 1,000 billion. You can imagine that by the time we really have 1,000 billion of these devices, every individual on Earth will have about 100 of these devices somewhere hidden in his clothes, in his products, in his car at home. So products will be embedded with intelligence in it and will be able to communicate with the outside world. And with that communication, a lot of data is being collected. data collection occurred already in the manufacturing environment. But once you start to equip every product with a smart device in it and which can communicate back to the service provider, you'll see that a lot of data is really collected. And you might ask why manufacturing industries really become so data-driven. Well, if you, as of today, design a product and give it to a few beta customers who test it a little bit, you can improve the product a little bit. But if you design a product from the beginning on, that there will be data in it, and that you can collect data out of it, all of a sudden all products going out in the market, you can trace what is being done with it. And therefore, with that data, you can improve the product continuously. But you have to store the data in the proper way. Today, what you'll see is that we have these digital twins in which we store already the design of it, the simulation sometimes of the product, but more and more also the manufacturing data of a product is really stored in it. And if you do that for every individual product, the next step is that for each of those individual products, you can start tracing them, what is happening in the field, such that if you would get them back later, you know exactly which parts are worn out and which you could reuse, for example. Now, having these products out in the market, you need to have a few things. If you start selling the usage of it, somehow you have to be able to trace the usage of it. That you could do with blockchain. Now, blockchain is not really ready yet. With Bitcoin, we proved that on the internet you can exchange things of value. Most internet uses is exchange of information, but with Bitcoin, you are able to exchange value. And with Ethereum, with if-then-else rules, we could do even a little bit more. But what is hesitating a little bit at this moment is the fact that with exchange of value, you also have to have a good digital identifier. And digital identifiers, of course, we do have barcodes, but if you remove the barcode from a material, you lose really that value. So it'll take some time before we really have come up with the proper digital identifiers. But once that's the case, you can go for tracing the usage of these products and the value that usage has, you can charge them. And then a lot of things will change. We now today have these value chains, but once you start tracing what the product is being used for, when you get it back, so that you can determine whether it can be reused or that it has to be refurbished first before it goes back to the following customer. Or even if you start to disassemble and store certain components and recycle other components, you really have all this data needs. Now, the question, how fast will this servitization development go on? And one of the things has to do with the cost of CO2. I'll explain this a little bit as an intermezzo. It's all about sustainability and to come to a carbon neutral manufacturing and production. The way to do it is to go for carbon circularity. And there are some costs involved in carbon circularity. The capturing, the transport, the reuse by solar panels, creating electricity, and out of the electricity with an electrolyzer hydrogen, and the combination of CO2 and hydrogen, you can create a methane again. That circularity costs a significant amount of money. What will happen is that those companies who don't invest in carbon circularity will face probably by that time taxation by government. And those who invest can gain a competitive advantage in it. Now, that's not so much the issue here. The issue here is that from the base materials like cement, metal, plastics, they will accumulate a lot of CO2 costs in it. So that by the time you sell a product to a customer, he gets access to the materials and he has to pay for the accumulated CO2 costs. So what will happen is that you probably will not sell the hardware. You sell only the solution in which he can use the hardware, but the hardware comes back to you. You know the best what the value is of the different components, and by reusing those components, you don't have to pay for the CO2 taxes again, and you avoid the further accumulation of costs in it. Now, with servitization, we do know that data collection is going to be important, is going to be the key. Actually, whatever we invest now already in the manufacturing environment in improving our capabilities of the area of data collection, data processing, data analysis is going to help to extend the business in the nearby future. So let's focus on manufacturing. What happened in manufacturing already was that shop floor equipment or control equipment went from a situation from 1:1, one input to one output, to a situation of 10:1 and even 100:1, in which you have 100 or 10 sensors for one output. And actually the amount of sensors really allow you to collect a lot of that data. Initially it was not going that fast, but at this moment with open source systems, you see that it's really exploding. And that means that we collect a lot of data, or we are able to collect a lot of data from the factory floor. The challenge now is, of course, to store it, after collecting, storing it, making sure that it goes in the right cybersecurity environments, and finally analyzing it. With all the data you then get, you have to store it. The way you store it really is creating a digital twin of the physical object. You can have them at multiple levels. Of course, with a sensor, for example, temperature sensor, the digital twin only contains that it is a sensor and that it has a temperature value. At a higher level, you can put more information on it. If, for example, it is a warehouse, you want to have not only the temperature, the humidity, but also the status of the warehouse, which doors are open, these kind of things. And with a product, of course, you can even have more on it. So digital twin is not only about the products out in the field in the nearby future, or the products that are being produced, but you can have a digital twin of your equipment, even a digital twin of your whole factory. And that one is being loaded with all the data. The way you do that really is with an object tree. And that's why I prefer to use the OPC-UA standard in equipment interfacing. In OPC-UA, you have this object tree available and you can use it immediately with XML to fill these digital twins on it. That's quite important because what we see an enormous transition from closed systems to open systems, systems which you can program yourself with Python, where a lot of standard libraries are available free of charge, and where these open standards as OPC-UA are being used really. Now, I used the previous picture and especially this subset of that picture on explaining or stressing again that cybersecurity is so important in factory environments. Decouple your network from your office network. Only have a firewall in it which allows only the transmission of OPC-UA messages and block it for everything else. That's a pretty tough configuration, because in your production line you don't want to have any cyber hacks. It's not only because of the information threat, but also in the production lines it could be even having personal injuries when a cyber hacker gets access to it. And the only way to do that is put a production line or equipment in its own subnet, put a firewall in it which you really block for in and outgoing traffic except for this OPC-UA standard. And make sure that in that production line there are no USB ports available. There's no Wi-Fi in it. If you really want to have Wi-Fi access on the factory floor, it's from the engineering network, but not from your production line. Really shield it off, such that no cyber hacker can get into it. Then you get this situation that, of course, you have your own production environment. You see it here, separated. But all the data goes through your manufacturing execution systems, your ERP systems, those kind of things. And in the long run, you'll want to store manufacturing information into the digital twin representing a product which is being produced. Realize that it is not going to be the data you have extracted from your own production process. It's also the data which comes from the whole value chain, from the logistics and the suppliers there, which probably deliver also a lot of manufacturing quality tracing data. And as I explained, all the investment in managing this data, getting on top of it, making sure that you do it in the proper way, is also applicable later on for the service department once that starts to evolve into a servitization business model or even a separate company if it becomes an equipment service provider. The thing there is that equipment will be within another company. So an OPC-UA standard is not enough. You need to do more on that one. And that's why we have these industrial data spaces, or what we also call a manufacturing data platform. Realize that if you do have data within your company, part of the data could be shared with someone else, your supplier or a customer. Now, what we see quite often is that data which could be shared with others going to a central place. And then you get this vendor takes all kinds of things, which a little bit is happening now with the cloud platforms. However, what you really want to do is you want to have access to other one's data as well, so that you can really do more than before. Before, you had the situation you only had your factory, you produced the product, you sent the product away, and you couldn't see anything anymore. If you would be able to see what the status of the product in use really is, you can advise or give services to your customer. So sharing data requires a lot of legal discussions, also traceability. And that's probably the reason why you can't use OPC-UA simple for that, because you have to have all these legal agreements around it. This traceability, clearinghouses, identifiers, all these kinds of things. That's now being defined in these concepts as the industrial data space. Started as a way of communicating between different companies, exchanging data information between companies in a proper way, but now also between clouds. And then we end up with something which is also in development, Gaia X, for example. Now, why is this so important? It's pretty simple to get your information from your supply chain. Well, if you're part of the supply chain, realize that it is a complicated thing. It's not simple that a product has a simple, straight supply chain. It's quite often a bill of material, and even in the supplies, in the different components out of the bill of material, it could be different suppliers. And then a supplier itself can be in multiple value chains. So the warning there is that in the whole logistics and the ambition to go to deep chain real-time plannings, it's not a simple chain. It's really a constellation. And that's why you need these manufacturing data platforms for. And that's what's now at this moment in development. And then this is going to be combined with what I show in this picture, the development from a third industrial revolution phase where we had economy of scale. It's going to be much more economy of networking. How well can you manage your network? How well is your network as a whole? You're not the only one managing it, but how well is your relation with all the other players in the network? Of course, in the nearby future, on the service part, but now at this moment, the focus is really on the supplier part. That's where, if you have this flexibility, this digital connection, then you can go to this situation that you have smaller factories closer to the customers, which can produce series of one, because all the information can be exchanged. And whenever there's something, interruption in the supply chain, this planning can immediately be seen, and you can find others doing the supply. That's really the robust supply chains which will be necessary if you have these more flexible factories. So what I'm trying to say in manufacturing, that a lot is changing. First of all, the big factory with the economy of scale will evolve into a much more flexible manufacturing situation closer to customers, where there is a supply chain which is flexible as well, but which can only function if you have this real-time information exchange, even to the level of deep chain planning and control, you could say. Therefore, we need these manufacturing platforms. Initially manufacturing platforms, but in the nearby future also for the servitization part. Whether we then still would call it a manufacturing platform, I doubt, but call it a data ecosystem. Then in those environments, those industrial ecosystems in which all this data can be exchanged in proper way with all the agreements for it, you really get it into a situation that manufacturing is not anymore about physical goods and all those things. It's much more that you want to create value with all the data which is available there. So a little bit coming to conclusions. I introduced this presentation with explaining the acceleration of digitalization. Clear that the importance of data is really growing. I explained that by the servitization side. If I would explain it from the supply chain, it's immediately clear. But my warning is, it's not only about your own production, it's the supply chain, and it is going to be the usage of your products. So in the end, it's all about this continuously learning by people to deal with these kind of new environments. Now I'll come to my conclusion slide. I started the presentation with acceleration of digitalization, the technology developments on the Internet of Things, edge computing, digital twinning, these kind of developments. I also mentioned that at this moment, there is a growing importance of data. I really explained it that it is not only in your value chain where you want to have deep chain planning, but it is also in the servitization once your products are being used. And that it requires a lot of data analytics and also security, legal aspects, but really this data ecosystems. Maybe the biggest challenge is really getting people on speed to understand it and to train them in the digital skills. Realize that 1% of the companies are really smart and are doing it already. Quite often big companies at the end of the value chain, you see it. The challenge is to get the next 10%. The thing is that all the technology is there. some could be developed a little bit further, but it is there. It's much more the challenge of training the people to start using it, that they have the basic skills to implement it in their environment. And after you reach 10%, the challenge is what to do with the other 90%, because they also have to do it. I mean, it's not only one supplier. It means that all your suppliers, second and third supplier, but also at the customer side, the customer has to understand also what and how and why you are extracting all the data out of the equipment and how you deal with that in a legal and cyber secure way. So my warning is really on the biggest challenge in this whole Industry 4.0, industrial revolution, smart industry, whatever you name it. It's going to be providing digital skills and training environments for the existing employees. And this is, for example, as a final slide, some of the skills I think which will be needed. Thank you for the attention.